We're going to discuss how failovers and elections work in MongoDB. The primary node is the first point of contact for any client communicating to the database. Even if secondaries go down, the client will continue communicating with the node acting as primary until the primary is unavailable. But what would cause a primary to become unavailable? A common reason is maintenance. So let's say we're doing a rolling upgrade on a 3-node replica set. A rolling upgrade just means we're upgrading one server at a time, starting with the secondaries. And eventually, we'll upgrade the primary. Rolling upgrades are great because they allow us to perform updates while maximizing availability to any clients using the database. We'll start by stopping the MongoDB process on a secondary, and then bringing it back up with the new database version. And we can do the same thing to upgrade our other secondary. When all of our secondaries have been upgraded, it's time to upgrade the primary. But restarting the database server on the primary would trigger an election anyway, so we're going to safely initiate an election with rs.stepdown. Once the election is complete, the last database server running the old database version will be a secondary node, so we can bring it down and then bring it back up with the new database server without affecting the availability of the whole replica set. Let's talk a little bit about how elections work. Elections take place whenever there's a change in topology. Reconfiguring a replica set will always trigger an election that may or may not elect a new primary. But you will definitely see a new primary elected in two cases: anytime the current primary node becomes unavailable, or when the current primary node steps down to be a secondary. The method to figure out which secondary will run for election begins with priority, which we'll discuss in a minute, and whichever node has the latest copy of the data. So let's say every node in our set has the same priority, which is the default unless we've been setting priorities for the nodes in our set. And this node has the latest copy of the data. So it's going to run for election and then automatically vote for itself. Then it's going to ask the other two nodes for their support in the election. And they're going to say, all right, you have a pretty recent copy of the data, you seem like a good candidate, and then they'll pledge their support as well. This node would be elected primary. There is also the very slim possibility that two nodes run for election simultaneously. But in a replica set with an odd number of nodes, this doesn't matter. These two nodes are both going to run, which means they're both going to vote for themselves. And then this node is going to essentially decide which one of these nodes becomes primary by virtue of a tiebreaker. This becomes a problem when we have an even number of voting members in the set. If two secondaries are running for election simultaneously, and there are an even number of remaining nodes in the set, there's a possibility that they split the vote and there's a tie. Now, a tie is not the end of the world, because the nodes will just start over and hold another election. The problem with repeating elections over and over is that any applications accessing the data will have to pause all activity and wait until a primary is elected. An even number of nodes increases the chances that an election has to be repeated, so we generally try to keep an odd number in our replica sets. Another important aspect of elections is the priority assigned to each node in the set. Priority is essentially the likelihood that a node will become the primary during an election. The default primary for a node is 1, and any node with priority 1 or higher can be elected primary. We can increase the priority of a node if we want it to be more likely that this node becomes primary. But changing this value alone does not guarantee that. We can also set the priority of a node to be 0 if we never want that node to become primary. A priority 0 node can still vote in elections, but it can't run for election. Let's take a look at how to change the priority of a node. So here I'm just storing the configuration document in a variable. So here I'm just setting the priority of one of our secondaries to 0, so it can never become the primary node. And here I'm just saving the new configuration in our replica set. So now that we've reconfigured our replica set, I'm going to run rs as master to see the new topology. So in MongoDB, nodes that aren't eligible to become the primary are defined as passive nodes. And we can see the node that we reconfigured to have priority 0 has appeared in our list of passives. The other two nodes are still eligible to become the primary. Something I want to point out here. When we call rs.stepdown, it always tries to choose a new primary node. But in this case, other than the current primary, there's only one node that's eligible to become the primary. Which means that if we were to call an election right now, this node would have to become the primary node. So incidentally, by changing node priority, we've rigged the election in favor of this node. So just to prove our theory, we'll call an election on this replica set. Just have to wait for the election to complete. Alright, so it finished, and I'm just going to check what the current primary is. And we can see that we were right. This node became the primary node because it was the only eligible primary in that election. So one last thing to note. If the current primary can't reach a majority of the other nodes in the set, then it will automatically step down to become a secondary. In a 3-node replica set, a majority is 2 nodes. So if 2 nodes go down, even if the primary is still available, it will step down. At this point, an election cannot take place until enough nodes come back up to form a majority, and the clients won't be able to connect to the whole set because there is no primary. So just to recap, we've covered how availability is maintained during elections, the effect of priority on elections, and the behavior of a replica set when a majority of the nodes are unavailable.